This last example for P7 is called the projectile motion model. I'll also just refer to it as the vertical motion model because we're looking at an object launched up and how high it is from the ground. We're not really worried about the horizontal distance that it covers. But with the projectile motion, what we have is an equation right here. This equation is going to describe the path that the projectile will take. And a few things that you should note here is that S sub 0 means the place where it's launching from. So this is the initial height that an object is launched from. V sub 0 is the initial velocity. And remember that one of the differences between velocity and speed is that velocity can be either positive or negative. Speed's just a positive number usually. And then S, that's just a kind of like the y variable in this case, but S means height. I'm not sure why they chose S as the height variable, but when you're talking physics, they've always used it that way, so I'm not gonna question it. We have this vertical motion model, and what we're going to do is take a look at this particular problem. This is this example here. The projectile is launched straight up from ground level with an initial velocity of 272 feet per second. So initial velocity, okay, that goes right there. We're going to make an equation out of this to start with. S is just a variable, it's going to stay a variable. T is like our x value. But then negative 16 t squared, that's always going to be the way it is, plus 272 is our initial velocity. Question here is, what's our initial height? S sub 0 says it's launched straight up from ground level, so the ground level is 0, so we don't have to put anything there. We just have this as our equation. Now what we're going to do is have the calculator help us figure some of these things out. So I'm going to go over to the calculator now. And take this equation, and I'm going to enter it into y1. Now, most of us, when we have the default on our calculator is to be in Zoom Standard. So it's possible that your graph looks like this, but you'll notice that there's nothing on this graph. We need to change the window in order to make this show up. And now I want you to notice here that it gives us some clues. It says, when will the projectile's height above the ground be 960 feet? Now, the height in this case is our y variable. So we're going to change this. Let's go to the window. And let's get to at least 960 on the y's. Let's make the y max 1,000 just to see how far we need to go yet. Negative 10 for the y minimum is fine. For the x's, let's just see where it's at for now. If we put 1,000 to the y max and see how high it goes. All right, well, nice thing is that we can at least see some of the graph, but it looks like we're going to have to go up and over some more. So I'm going to go back to my window, and maybe I'll just double each one of those to see if that gets at the x max and the y max. If we double those, maybe we'll get some values in there. Yeah, that's good. That gets everything. So we can see the entire curve now. So the questions, notice the questions say, when will the projectile's height be 960 feet above the ground? When will it be more than that? When will it be less than that? So here's the other thing that we need to do in this problem is we need to figure out where 960 is. Now we could trace it and just try to get 960. For some reason it is at 960 already. That's kind of nice, I guess. But the way that we can do this to be a little bit more precise is to go back to y equals, and let's put 960 in for y2, because that'll just give us a horizontal line. And now that clearly shows us, okay, right, kind of right in this area up here is where it's going to be above 960. So if we want to answer these questions, here's what we do. We go to the calc menu and find out where they intersect. What values do we have there? So actually we're probably okay for this one. Looks like x equals 5 is where they're going to intersect. So I'm just going to write that down over here, x equals 5. And then I'm going to do the same thing again. I'm going to find the intersection over here, getting as close as I can. and it looks like x is equal to 12 is our other spot. So if I make a quick sketch of this one on my sheet here, it's x equals 5 and x equals 12. Now this is going to be the amount of time in seconds, because you notice it says feet per second and it's position in feet of the object after t seconds. So this is in seconds. Now the only thing that I also might want to know, this is going to be x equals 0. I also might want to know when it hits the ground, because it's not going to go on forever. It's going to hit the ground and then stop. And so one other thing I might do is come over here and try to figure out when it's going to be equal to 0. It doesn't, not quite able to get there. If I have an idea, then what I can do is I can just actually type it in. It looks like it's really close to 17. So if I'm tracing already, I'm going to type in 17 because I think that's what it is. And it is, in fact. So x equals 17 is where it's going to stop. And so now, when will the projectile's height be height above ground be 960 feet? Well, that's going to be at each of these individual points. So 5 seconds and 12 seconds. When will it be more than 960 feet? Well, this is where interval notation comes in. We can do between 5 and 12, which means that we're going to go 5 comma 12, and since we want it more, it's not greater than or equal to, we're going to have rounded brackets there. So that's expressing it in interval notation. When will it be less than or equal to 960? Here we're going to use some square brackets. It goes between 0 and 5 for one thing, so that'll be our first piece. 0 comma 5 left to right. And then it also goes underneath from 12 to 17, and so we'll do that as well. So you'll see a problem like that in your assignment. There's a lot to it, but use your graphing calculator to help you with that information. And as always, feel free to ask me questions in class or on the Google Meet.